Hello everyone. So this week we don't have access to the temple building. So in that case, we're going to use a PhET simulator to complete Lab 7. Lab 7 is conservation of energy. So if you are not familiar with the theory, you may watch the below video with the where I explain the theory. If you're familiar with the theory, you may download the lab manual and start working on it. So in this video, I'm planning to go over the simulator and introduce you to the functions in the simulator so you can complete your lab report properly. So let me share my screen with you. So when you go to your Blackboard page, you should be able to see Lab 7 Conservation of Energy, and you will be seeing two documents that I attached here. One is the lab manual in PDF format. The other one is the Word document. So if you're familiar with the Word, you may download this file and type on it and save it as a PDF and submit. So it's easy for us to grade your lab report. So basically your TA will be grading it, not me. So if you are trying to email me your lab report, it doesn't work. So please email your TA for help. And also we are not accepting your reports through emails. Please submit through Blackboard page. Well, so we need a simulator, right? So if you click on this one, it will open you to a simulator and you need to open it on your browser. Well, there are some software requirements. So depending on which machine you are using, so if you have Windows, it will easy, but you need to have Java on your computer. Anyway, so if you are facing problems, you may try any of this, and also you may watch this video if you're using a MacBook. Well, so if you're ready to open the PhET simulator, when you click on that link, it will open to a page like this one. So basically you need to open it, right? So you don't need to download or embed it, you need to open it. So you just click on this picture. If you're using a Windows like me, then it will give you a command like this type of files can harm your computer. Do you still want to keep it? Yes, I need, because I trust this website. So I'll keep it and it will open you to the simulator. So let me open or share the simulator with you. It's something like this. Okay? So here it is a roller coaster, right? So there's a skater. So I will talk you, I'll show you the functions available. So here, if you click on the choose this skater, you may pick your skater. So basically we're going to use a PhET skater who is 75 kilograms mass, right? And also if you want to reset, you may hit the reset button at any time. Yes, I want to reset, right? So pause the simulator over here, and again, so if you want to choose the skater, you may click over here and pick the skater, and then this gives you a potential energy reference line, and you can move it as you wish. So if you want to keep the ground as the zero potential, you may keep it over there. If you want to call the mountaintop as the zero potential, you may move it as well. If you need somewhere in the sky to be zero potential, you may do that as well. Then you can take a grid line so you can read the skater's position properly, right? So we're going to read the grid over here. So these are the X values. So if you want to label this position, let's say I want to label this position over here, that's going to be 1, 2, 3. So 3 in X axis and 6 in the Y axis. So the position over here is named as 3, 6, right? So in the lab manual, it's asking you to set up the track using some notations for the position. So you may read the grid easily using this grid option. Then you can take a bar graph. So you can see like the variation of the energies of the skater. And also you can take an energy versus position graph like this one. So it's plots the energy on the y-axis and the position on the x-axis. And then also you can take energy versus time graph, right? So you need to have both of these. I'll come back to the energy versus time graph in a second. And then the other option is you can change the location. So, you know, the potential energy is depend on the gravity, because potential energy is m times gravity times height, right? So here you can change the location to moon or Jupiter or even to the space and try what happened to the skate, right? All right, so let's keep it on Earth. So the gravity is 9.8 meters per second squared. And also you can add a friction to the track. You know, like in real life, there are so many friction forces acting on us. But in the physics world, we always try to neglect the external forces to make our life easy. So in the first part of the experiment, you will be keeping the non-zero track. So basically you can move this cursor to make it lots of friction or make it none. Okay. All right. So before you move on, let's check whether we set it to zero friction. So let me take the bar graph. So here I can see the kinetic energy, potential energy, thermal energy, and the total energy. So if I move this skater, there's no thermal energy. That means the friction, the track is frictionless. But if I add some friction into the track, you'll be seeing thermal energy. You know, there's a friction, so it heats up the track and the skater, so it will produce the thermal energy there. Well, we need to keep this zero friction for the first part of the experiment, so keep it none, and make sure you click somewhere else to get rid of this friction setting. All right, so we good. Okay, so let me take you back to the energy versus time graph, because it is important to read the energies over here. So if I run this skater, this will read the values, right? So here again, see, the thermal energy is not equal to 0. That means I didn't set this one properly. So hit clear heat, so it will set it to 0. All right, let's run it again. All right, see, there's no thermal energy, right? Okay, so let me clear the data. You can clear the data. You can stop the skater here, and you can clear the data. So you can start from the scratch, right? All right, so let's move this skater a little higher in the track. So let's say I want to start it a little bit higher in the track, and let's play. Go. Okay, so it's giving us a nice graph here. And the blue color graph reads the potential energy, while the green color graph represents the kinetic energy, right? So let's stop. And you can go to the playback mode, so you can analyze the position. So let's say I want to track where the man is in the lowest point of the skate. So you can move it, right? So here you can read the kinetic energy at that point and the potential energy at that point. See, again, it's adding up some thermal energy. We don't like it, so you can clear heat, and then run again. Okay. You have to move the person to the proper place and let him run, right? Again, you can clear the data if you want to. Right. So those are the functions that you might need to complete the lab report. If you have any questions, you may email your TA, but try to be in Zoom meeting. So it's really useful, and that way you can get the real-time help, and that will save your time and our time as well. But if you're facing any technical difficulties, you may email me. Okay, thank you and good luck. Stay safe.